7.6. Moving on. Rewriting quadratic expressions in factored form. Now we're going to have to start figuring out how to work backwards and get from standard to factored. We haven't done much of that. This one's going to be super important. You can see this is part one. I think there's 4 parts. Going to be lots of practice. Earlier you get this, the quicker things will go for you. First example, okay, kind of like solving a puzzle. How do we get the area based on the information that we have of that little piece there? Okay, can you find the missing area in figure A? And then you notice figure B has one missing length with the question mark. I'll give you a minute or so to see if you can decipher what's missing there. Can you find it?
Oh, you mean the blue square? A rectangle?
Yeah, so the first one you're looking for the area of the blue part. Second one you're looking for the missing length where the question mark is on the top right there. And there are different ways to go about it. Just see if you can problem solve that. Both. All right, anybody think they have either one? I think I gave you more than a minute.
Is the first one square? It's just 24.
Nope.
I think I got the first one.
Was the A 20 square inches? Is that what you said?
She said 24.
I got
Right.
20.
It's right.
I got 20 as well. Want to share either one of you how you got it? Go ahead.
So the height of the whole thing was 10, but just for the thing is 8, so that means it's 2 on the left side. And then,
So this whole thing says 10, this is 8, so that means this must be 2. Yep.
yeah, and then since the whole thing was 5 on the right side and there's 3, that means that I don't really remember after that all of the others, but
Yeah, so this whole thing is 5, that means this has to be 3, right? Same as this. This has to be 2. This part of it is 8,
so yeah, then it's 10.
so that whole thing is 10, so 2 times 10. Yes, and this one's similar to that. This one's a little trickier. A lot of people get stuck, they're like the 36, well, what times what is 36? I mean, it could be 4 and 9, 6 and 6, could maybe not even be a whole number.
Is it 9? Because that's what I got.
Yes, it does turn out to be 9 now. Now, how do you get that?
The whole length of like that long line down the middle is 18, and then I subtracted 14 to find 4.
Okay, what
That's
line?
kinda like
What line?
the one on the bottom of the top rectangle, but
Here?
no, the horizontal line
Oh.
on the top.
Yeah, so the first one I looked at, and again, there's different ways to do that. I see this being 60, Well, 12 times what is 60?
5.
5, so this would be 5. Okay, that would be 5. Could figure out this side. So this has to be 8 times 6 would give you 48.
Yeah.
So if that is 6, this whole thing is 11. So if this is 6, that means this has to be 5. Whole thing is 12. 5 plus 3 is 8, so this has to be 4. 4 times what is 36? 9.
I did it in a way more simple way.
Yeah, and that's fine. There are different ways to do that. As long as you get to 9, all right? As long as you get to 9. When we do the factoring, there's gonna be different ways to get there. As long as you get to the answer, it doesn't matter. All right, question number 1. Use diagrams to show that each pair are equivalent. So it says both of these are equal, right? Again, diagram arrows doesn't matter to me. I think the first one there is pretty simple. X times X, X times 3. You can see that they are the same thing. Same thing for the one on the right. X times X is X squared. X times negative 6, negative 6X better be the same thing. This one, let's review diagrams just in case you're still liking to use that. X and 2, X and 4. Again, you prefer FOIL, that is perfectly fine. X times X is X squared. X times 2 is 2X. 4 times X is 4X. 4 times 2 is 8. Combine like terms. Like terms are right here, both have an X on them. 4X plus 2X is 6X. And 8, they're the same. Okay, why don't you try the one on the right? FOIL or diagram, up to you. Again, you know what you're supposed to get, just prove it. You gotta show it.
No.
Because you know what it's supposed to be. You can't just write X
I
squared
didn't
plus.
even look at that side. I just did it in my head.
I mean, then you better show this.
Yeah, I know, but that's transport.
Can you slide it over so I can see the one you just did?
The diagram.
Diagrams are more confusing than like.
That's fine, then don't use a diagram.
Well,
Some people like the diagram.
I thought you would people that do these like the diagram is just because they know which order it's supposed to be in anyways.
Usually when they're both pluses, people don't have an issue. Right? When they start throwing negatives, then it gets a little more confusing. Cover up the one on the right, foil that thing. Again, if you need a diagram, go ahead and use it. Done with that one, go ahead and do the one on the right as well.
But that's right.
Saying that's right?
I said, is the sign right?
No.
I did it
Both of
opposite.
them
Oh, yeah. Wait, but I don't get,
are. I can do it in my head, Mr. Milbrand.
okay, the signs are
I
different.
told you it was harder with the signs being negative.
I didn't say that it wasn't.
All right. Again, you need a diagram, do it. Excuse me. X squared minus 7x
Okay, Mr. Miller.
minus 1x plus 7. Watch the signs. Can't handle foiling it or doing it in your head? Diagram it.
I'm not drawing a
If you're doing it in your head, then I better get it right.
Okay, I will.
It says, observe the pairs of expressions that involve products of two sums. How is each expression in factored form related to the equivalent? So what it's saying is, look at the middle term and the last number, and look at this 1 and 7. Okay, so when you're doing these, when we're going to work backwards, you're thinking of factors of 7 that will add up to 8. Okay, factors of 7 that add up to 8. And 7 and 1. Factors of 5 that add up to 6. And it's nice when it's a prime number. The only factors of 5, of course, are 1 and 5. You're going to see ones when you have factors of 12. If that last number is 12, how many different ways can you multiply to get 12? Well, 1 and 12, 2 and 6, 3 and 4. There's a lot more choices there. Okay, a lot more choices. All right, so let's start on some. When it gives you factored, we should very easily be able to get standard. Okay, you can see they give us a lot more the other direction. We're going to do a lot of those. So let's just FOIL the first one. X times x. X times 7. Okay, when we only have two terms, it's pretty simple. What can I take out of x squared and 9x? What do they have in common? They have an x left. So if I take an x out of here, what do I got left? An x. If I take an x out of here, what do I got left? A 9. Yep, and it's a positive. Absolutely. Done. Next one, what can I take out of there? Take an x out. They both have an x. What am I left with if I take an x out of the first term? And I take x out of here? Minus 8. Negative 8, doesn't matter. But you do need the sign. All right, next one, go ahead and FOIL that. See what you get. Draw a diagram if you need to. Ken, got it? What do you got?
X squared plus 8x plus 12.
That's very good. All right, now our first one where we actually have to factor. Okay, trinomial, 3 terms into 2. So again, factors of 12. 1 and 12, 2 and 6, 3 and 4. That's going through my mind. We can always trial and error. More of these you do, the better you will get at them. So I need factors of 12 that will add up to 13. 12 and 1. Order you write them in does not matter. That is my factored form. You can always double check, FOIL it, and see if you get the thing on the right. Notice, if both of these are plus, both of these are plus. Okay, notice that. Next one's going to be the opposite of that. If I have 2 negatives, what will the one on the right always look like? Go ahead and FOIL it. Watch the signs.
Did I do it right that time? Because when it's multiplying, I can't do that. That's what you told me.
You're not multiplying. You have a negative 2x and you have a negative 6x. And you're combining like terms. All right, you should be left with x squared minus 8x plus 12. And again, that's x squared. that is a negative 6x, that is a negative 2x, and that is a positive 12. You combine like terms. You're adding, you are not multiplying those together. Negative 6x and negative 2x is a negative 8x. So, notice, anytime you see two negatives here, you're going to get a minus and a plus. That is always the pattern. So if I see a minus and plus here, that means both of these will be negative. Because that's the pattern, minus, plus. Minus, plus, minus, plus. So for all those, I can make note right away that these will be negative. Because that's the pattern. Sooner you catch on to that, the easier this will be. So I want factors of 12 now that will add up to negative 7. 4 and 3, 3 and 4, order doesn't matter. Next one. Now I got a 9 on the back. I'm thinking, all right, factors of 9. My choices are 1 and 9 and 3 and 3. They are both plus. That means both of these have to be plus. Oops. Guess I gave you the answer. What do you think the next one's going to be? Factors of 9 that add up to 10. 1, 9. 9 and 1. Order doesn't matter. Why don't you try the last two? Got it? Factors of 9 add up to negative 10. Negative 1, negative 9, order doesn't matter. Factors of 9 that add up to negative 6. 3 and 3 add up to 6. Anybody think they have the last one? Only two things that would give you x squared would be x times x. Only thing that would multiply together to give you mn would be m and n. You need to have those two added together with an x. That's just the generic equation when you have two pluses. All right, we are going to skip the, are you ready? Again, you can always draw diagrams. Some terms I would like to discuss. Anytime it discusses linear term, remember that means it has an x on it. Anytime you see the term coefficient, that just means a number in front of the variable. Constant term is the number by itself. Okay, 20 is a number by itself. That is our constant term. Again, what I like to do when I'm doing these is look at that last number and write down the factors. The bigger it is, the more choices you have. You can always trial and error. Factors of 24. Well, my choices are 1 and 24, 2 and 12, 3 and 8, 6 and 4. So quite a few there I could try. And then it's all right, how do I get to 11? Using those numbers. Better you get, the more you might not need to use those, but I do like to include that early on while I'm learning how to do these. All right, assignment. Starting on page 202. You might have more choices than just one answer possible for the first few. It says find numbers that multiply to 17, add up to 18. So numbers that multiply to give you 17, but add to give you 18. Can you figure that out? What is it? 1 and 17. Absolutely. Okay. So A is done there for you, 1A. 2, just using the diagrams. 3, select all. 4 is what we were just got done doing in that chart, except it's only asking, all right, what goes in these boxes? Okay, fill it in. Question number 5 is what we did a couple days ago. Question number 6, it says one of these inputs is impossible. Which one there is impossible? Okay, 7 is a review from Unit 4. Remember, this is the number that gets plugged in for X. Domain means, all right, what X's will work for our equation? What X's will always work for our equation? 8, you can use Desmos to help you with that. It does say technology will be helpful there. So once again, only 8 questions. You can go ahead and get started on that. 202 to 204 for Monday.